So let's do an AP self-quiz on volumes, distant washer method using dx and dy. So the first one here. Find the volume solid obtained by the region bounded by square root of x, which would be this guy. That's the square root of x graph. And y equals x squared, which would be this guy. About the x-axis, rotated around this guy. So we're going like that. So that's a vertical one. That's normal. It's top minus bottom. We do need to find the intersection though. So that's going to be helpful. So let's set them equal to each other. X squared equals square root of x. And then we just solve it. So we'll square both sides. I get x to the fourth equals x. Set equal to 0. That's why we solve this. X to the fourth minus x equals 0. Split it. Or factor it out. There we go. So you get x equals 0 and x equals 1. Give or take. So here's 0. And then here's 1. Just like it shows on there. So that's right now. That is 1, 1. In fact, that is 1, 1. Anyway, so if we're going to rotate around x right here. So we want to find this little region right there. That's going to be a washer method. So if you remember the washer method, it's pi integral big R squared minus little r squared dx in this case. So let's find our big R. So we're rotating around this guy. So we go up until we hit the farthest. That'll be this. That's my big R. So that's going to be top minus bottom, rad x minus 0. So big R is rad x minus 0, which is just rad x. Little r, start here, go to the smaller one, right there, that's little r. And that's going to be x squared minus 0, or just x squared. So once we have that, we type it all, we plug it, sub it into our formula. We're going to go from 0 to 1 of big R, which is radical x squared minus little r, x squared dx. Then we just type that into our calculator. So in this case, let's go math 9. On these, I honestly, I like to, it gets a little messy putting squared. I just like put it in here. So square root of x, and okay, and this one's easy. I'm not gonna worry about that. So let's do pi math 9 0 1, and then I'm gonna do square of square roots. That's just x minus x squared x to the fourth. So the x power, I mean, I probably could do this with my hand, and I get this, right? So we get approximately 0.94247 or 0.942. If I didn't do it with the pi, what happens if I took the pi out? Sometimes I just like to do it without the pi and just add pi to the answer. We would have got 0.3. So 0.3 pi, 1/3 pi, or that's 1/3 pi, 3/10 pi, sorry. Or that decimal. So next one, same idea. We're y equals 2. We're rotating against y equals 2. So that's up here. Flipping across y equals 2. So we're also going vertical on this one. So it's kind of the same idea, right? We're gonna have pi big R minus little r squared dx. We're going from 0 to 1 again. But now r's are different. So our big R, so you're starting here. Right, this is 2. You go to the furthest one, so that's down here. So my big R is going to be 2 minus this equation, which is x squared. So that's my big R. My little r goes from here to here. So my little r is going to be 2 minus this equation, square root of x. So let's type it in. So pi 0 to 1, big R 2 minus x squared minus little r 2 minus square root of x squared dx. And then we're going to type this into our calculator. So I'll put the pi in this time. Pi math 9 going 0 to 1. And then right here we're going to go parentheses 2 minus x squared close parentheses, square that, minus parentheses, 2 minus square root of x, move it to the right a little bit, get out of there, close parentheses squared. I think I don't need to close that parenthesis, I think it's already implied. Go over here to the edge, and then press X. And with that, we get about, let it think, 3.26. Approximately 3.246. So you get that. This was the next one. So now we're going to go right and left. So find the volume of the solid obtained by rotating the region bounded by 4 minus y squared and about the y-axis. I think I want 4 minus y squared and quadrant 1 and or x equals 0. I think that's I missed that point. I want that there too. So like the first one here. My intention is for it to be x equals 0 and this. Now if you look at the graph, we can tell it's going from -2 to 2. It's already in, how lucky for us, it's already in terms of y. So we just gotta know to go right minus left. So this is going to be this method. So we're just going to integrate our r squared dy. We're going right minus left, so dy. Our right is this guy. So if we're doing our r, right, our r is going to be from here to here. Right minus left, that's going to be 4 minus y squared minus 0. So we're just going to get pi from -2 to 2 of 4 minus y squared dy. Now if I put that in my calculator, remember we don't have y in the calculator, so you just use x. It works the same way. So put second pi math 9. And we're going to go from -2 to 2. Then right here we're just going to put parentheses 4 minus y squared, which in this case is x squared. Close parentheses, square it, and then dx. So again, to work the exact same way, we get 107.223 approximately. Next one, same idea, but now we're going to rotate across the line x equals -2. So again, we still want this portion, where this is still 4 minus y squared, and this is still x equals 0. But now we're going to rotate it around the line x equals -2. So this one's going to be a washer method. We're going to have a big R. Right, big R is right minus left, so 4 minus y squared minus -2. So I'm going to get the same thing as this 6 minus y squared. So do that over here. We have space. 4 minus y squared minus -2. So it becomes a positive 2. So I get 6 minus y squared from big R. My little r, from here to here, that's going to be 0 minus -2. Put it right here where I have space. So I just get 2. So we're going to use the washer method. So pi big R squared minus little r squared. We're going from -2 to 2. Which will give us, put in our calculator, for a little ease. So in this case I got 6 instead of 4. That's all good, that's all good, that's all good. And this is all good, that's fine. Minus 2 squared. Plug it in, I get 241.274. And that's it.